Hello. So this email is a recap of polynomial factoring that we did before spring break, but I just wanted to work through a few examples just to remind you what's going on. First of all, we're going to look for a GCF. Then we're going to determine the number of terms. If there are two terms, we've got two options. It could be dots, or it could be a sum of cubes or a difference of cubes. If there are three terms, we're looking for a perfect square trinomial, or we might just be looking for general factoring, AC method or whatever. If there are four terms, we are looking to group to factor, so that might mean pairing things up that have a GCF, or finding a trinomial that's a PST. So I'm just going to work through a bunch of examples, use the ones that you need. All right. First example, there is a GCF, so I'm going to start by factoring out the GCF, which in this case is x, and that leaves me with x squared plus 2x minus 15. In this trinomial, it's still factorable. It's three terms. It's not a PST because 15 is not a perfect square. But 15 does have factors that would add together to give me 2. So the GCF comes along. This factors into two binomials where the factors are 3 and 5. And I need a positive 5 and a negative 3. So that is my fully factored solution for part A. For part B, again, first of all, there's only two terms, but I'm going to start with a GCF. There is a GCF. The GCF is 2y cubed. And if I factor that out, that leaves me with a y squared minus 9. Now, everybody should note that this is the y squared minus 9 is only two terms, but it's a dots. It's a difference of two squares. So I'm going to factor that out into y minus 3, y plus 3. Just as a recap, remember dots is a squared minus b squared. If you have that pattern, it factors into an a minus b and a plus b, or a plus b, a minus b. It doesn't matter what order. All right. Moving on to example number 3. On example 3, there is a GCF, and the GCF in this case is 4z squared. So once I factor that out, that leaves me with a z squared minus 4z plus 4. Because I've been doing this a long time, I immediately recognize this trinomial. I immediately recognize this trinomial is a PST. It's a pretty common one. But if you don't, you would factor 4, and the factors of 4 are 2 and 2. So this becomes 4z squared z minus 2 z minus 2. On page 354, there's some different examples. So let's start with x cubed plus 64. First, there is not a GCF. There are only two terms, and they are not, the first one is not a perfect square, so it's not a dots. So that leaves me with sum of cubes or difference of cubes. It is a sum because it's added. And they are both perfect cubes. This is x cubed, and this is 4 cubed. So I just have to remember the pattern, which is a plus b, a squared minus ab plus b squared. In this case, the thing that I'd cube to get x cubed is x, so that means that's a, the x is the a. And the thing that I would cube to get 64 is 4, so that means the b is 4. So this becomes x plus 4 and then x squared minus 4x plus 16. So that's it. I just have to know that pattern. If I don't know that pattern, it's pretty difficult. I just have to memorize the pattern. All right, in the next example, 16z to the 5th minus 250z squared, there is a GCF again. Why do I keep using these? But our GCF in this case is 2z squared, which leaves me with 8z cubed minus 125. I've only got two terms. Neither of these are perfect squares, but 8z cubed is a perfect cube, and 125 is a perfect cube. So this is the thing that would be cubed would be 2z cubed, and the thing that would be cubed here would be 5 cubed. So those are my A and my B when I follow my pattern. In this case, the pattern is just slightly different with the signs. So it's A minus B, A squared plus AB plus B squared. So we're just going to follow that pattern. 2z cubed minus 5. And then 2z squared would be 4z squared. Multiply them, I would get, and I use the plus sign, even though it looks like it should be negative, I'm just following the, it looks like these should be negative, I'm just following this pattern. So when I multiply them, I get 10z, oh, there's a mistake, I'm sorry. This is just 2z, not 2z cubed. So this is just 2z and then minus 5. Okay, multiply them, I get 10z, and then square the last term, I get 25. So that is my final answer, factored answer. Okay, last example for this video. X cubed minus 3x squared minus 16x plus 48. There are 4 terms, so I'm going to group to factor. And I'm looking for ways that I can factor the problem completely. As I'm looking at it, I notice there's a GCF between these first 2 terms. And just mentally, if I take out the GCF, it leaves me with an x minus 3. So then I'm looking at these 2 terms. There's also a GCF. And if I take out the GCF, it leaves me with x minus 3. That is an excellent start. So I take out an x squared, and it leaves me with x minus 3. I take out a negative 16, and it leaves me with x minus 3. So this should look like the AC method when you were factoring, because these 2 things are the same. If they're not the same, you have a problem, and you need to probably factor in a different way. But those 2 things are the same, so I get x minus 3 as its own binomial, and then the leftovers, the x become x squared minus 16, and their own binomial. Be careful here, though. I'm not done. This binomial is a dots, so I need to keep factoring, and I get x minus 3, x minus 4, x plus 4. So that's my fully factored solution. Okay, so that's a recap of polynomial factoring so far.